Hello everyone, this is Dave, and today I want to talk about resistors. First, we need to answer the question, what is a resistor? A resistor is a device having a designed resistance to the passage of an electric current. This is what a resistor looks like on a schematic. Resistance is the measure of opposition to the flow of electric current. Resistance is measured in ohms. To get a better idea of how resistors play into the grand scheme of things, let's talk for a moment about Ohm's law. Ohm's law states that it takes 1 volt to push 1 amp through 1 ohm of resistance. Voltage is measured in volts, and it is the force that pushes electricity through a circuit. Current is measured in amps, and it is the amount of electricity being pushed by the voltage. Water is always a good analogy when talking about electricity. You could imagine that voltage is water pressure, and that current is the amount of water flowing through a hose. You could also imagine that resistance is the diameter of the hose. A smaller diameter hose would be more resistance, and a larger diameter hose would be less resistance. It takes more water pressure, or voltage, to push the same amount of water, or current, through a smaller hose, or more resistance. Now that we have a basic understanding of how resistance relates to voltage and current, we can begin to discuss how resistors are used. Another word for resistance is impedance, because resistance impedes the flow of current. This can be helpful in many ways. One benefit of restricting current is to protect other components. For example, if you hook an LED directly to a 9-volt battery, the LED will burn out. But if you put a small resistor before or after the LED, it will not burn out. It doesn't really matter which side of the LED the resistor is on, because either way, it is still restricting the current flow between the voltage supply and the ground. I personally like to put the resistor on the positive leg of the LED, because if the resistor is on the negative leg, and the negative leg of the LED grounds out on the enclosure encasing the circuit between the LED and the resistor, then the resistor between the LED and ground will be bypassed, and the LED will burn out. But if the resistor is on the positive leg of the LED, and either leg of the LED grounds out on the enclosure, then the LED will just shut off, but it will not be damaged. If an LED is too bright for your application, you can put a larger resistor in series with the LED to make it less bright. You can also use a potentiometer as a variable resistor, so that you can adjust the brightness of an LED with the turn of a knob. This is what a variable resistor looks like on a schematic. If you do this, you will still need a small resistor in series with the potentiometer and the LED, because if you don't, then the LED will burn out when you turn the resistance all the way down on the potentiometer. Without that protective resistor in the chain, direct voltage can also damage the potentiometer. Resistors can also be used to lessen the effects of other components in a circuit. One example of this is with a low-pass filter. A low-pass filter uses a capacitor to filter out high frequencies by sending them to ground and allowing the lower frequencies to pass through to the output. You can use a resistor either between the output signal and the capacitor, or between the capacitor and ground to restrict the flow of current through the capacitor to ground. Again, it doesn't matter which side of the capacitor the resistor is on. Either way, it is restricting the flow of current in that direction. This will result in less high frequencies being filtered out. If you want to control the amount of high frequencies being filtered out with a knob, you can use a potentiometer as a variable resistor in place of a fixed resistor. This will give you adjustable tone. This is the same way that a tone knob on a guitar is hooked up. You can use a potentiometer as a variable resistor by only using 2 of its pins, the middle pin and either outer pin of the potentiometer. If you connect one wire to the middle pin and another wire to the outer pin on the right, then when you turn the potentiometer all the way to the right, you will have no resistance. But if you turn the potentiometer all the way to the left, then you will have the full amount of resistance the potentiometer is capable of producing. If you want the opposite to be true, then you just need to connect one wire to the middle pin and another wire to the left pin of the potentiometer. Restricting the flow of current can also be useful in controlling the amount of current going to a circuit. In a simple transistor circuit, like a fuzz pedal, a resistor may be needed between the collector and the power supply to ensure the transistor is getting the optimal amount of current for the application. Because transistors are so mass-produced, there can be some variation between the qualities of the transistors even if they are the same model from the same manufacturer. This is especially true with germanium transistors. For this reason, many transistor circuits use a variable resistor, also known as a trimmer, in place of a fixed resistor at the collector, so that when the circuit is assembled, the amount of current going to the transistor can be dialed in just right. Some transistors use a variable resistor between the emitter and the ground to control the amount of gain put out by the transistor. If you don't have the correct value of resistor for the circuit you are building, sometimes you can use two or more resistors together to act in place of a single resistor of a different value. For example, if I need a 2K resistor and all I have are 1K resistors, I can use two 1K resistors in series to create 2 kiloohms of resistance. Or, if I need a 0.5K resistor and all I have are 1K resistors, I can use two 1K resistors in parallel to create 0.5 kiloohms of resistance. So two resistors of the same value ran in series doubles the amount of resistance. But two resistors of the same value ran in parallel will have half the amount of resistance. This is because when the resistors are ran in series, there's only one path for the current to go, and it must go through both resistors to reach the other side. But when two resistors are ran in parallel, the current has two paths to go through, and this creates less overall resistance for the current to get past the resistors. The most common measurements you will see for resistors used in small electronics will be ohms, kiloohms, or megaohms. 1,000 ohms is called a kiloohm, and 1,000 kiloohms is called a megaohm. When a resistor has a value of less than 1,000 ohms, it is usually labeled with the omega symbol, or sometimes just the letter R for resistance. Resistors with 1,000 ohms or more, but less than 1 megaohm, are usually labeled with K for kiloohm, and resistors with over 1 million ohms, or over 1 megaohm, are usually labeled with M for megaohm. If you have a resistor with 2,500 ohms, it may be labeled 2.5K, or 2K5. If you have a resistor with 3,500,000 ohms, it may be labeled 3.5M, or 3M5. A resistor with less than 1,000 ohms, like a 450 ohm resistor, is just labeled with the number, followed by either the omega symbol or an R. When I say that resistors are labeled like this, I just mean the packaging or the schematic. The resistors themselves are generally too small to be labeled, so they usually have colored bands around them that can be deciphered by comparing them with a color chart. Resistor color charts can be found all over the internet, but I find it is usually easier to just measure them with an ohm meter if you don't know what value they are. I certainly have not said everything there is to know about resistors, but I hope I have given you enough information about them to know how to use them in their most common applications. If you enjoyed this video, please give it a thumbs up, and if you would like to see more videos like this, please subscribe to my channel. There will be more electronics videos to come, as well as many other hands-on projects, ranging from forging to bushcraft to general DIY crafts. Thanks for watching.